This is video number 2 for sections 9.3 and 9.4, rationalizing a denominator containing two terms. In the last video, we only looked at situations where the denominator, the bottom of the fraction, had one term. But take a look at this first example. What if we want to get rid of a radical in the bottom, but there are two separate terms down there? How do we do that? And I can tell you just real quickly at the start that our prior trick is not going to work. I've got this square root, and you might think, oh, well, we'll just multiply by an exact copy of itself. You don't have to write this part down. Well, the problem is you've got two terms down here, so you'd have to distribute that square root to both terms, and that would work great with the first one. Root 3 times root 3 would be 3, but then on the second one, you have 2 times root 3. All that does is move the square root from being in the first term to now being in the second term. So our old trick really isn't going to work. We need a new strategy. And I've written it down up here at the top. By the way, you will be happy to know that we are only considering this two-term situation in the case of square roots. So no cube roots or fourth roots here, just square roots. If the old trick doesn't work, what do? It's called multiply by the conjugate. And that word might sound familiar to you. We have used it one time before in this class. It's when we were dealing with complex numbers. And I believe we were dividing complex numbers and we had to multiply by the conjugate. The conjugate means the same thing but with a different sign in the middle. Change the sign in the middle. Well, that same idea is what works in this situation as well. You take a look at your expression. If you're trying to rationalize the denominator and there are two terms, you multiply by the conjugate, and you'll see, I think, why that works. So all I'm going to do here is I'm going to come along and put down the conjugate of the bottom, the exact same thing, but change the sign in the middle. And of course, whatever I do to the bottom, I have to do up here on the top. And now I will multiply across. Now remember, with these two-term things, it's a little bit more complicated. It might help you to put parentheses everywhere to remind yourself what you're actually doing. On the top, it looks like I have a distributive situation. I'm actually going to hold off on the distributing for now, just to see if I have any common factors that I might be able to cancel later. I expect that I'll be eventually distributing this. On the bottom, I've created essentially a FOIL problem, and here's why this conjugate trick works. When you start FOILing, so I'm going to have square root of 3 times square root of 3, that's square root of 9, which is 3. The outer term is going to be minus 2 root 3. The inner term is going to be plus 2 root 3. I think you can see where this is going. And the last term, minus 4. Well, when you do an a plus b, a minus b multiplication problem, the middle terms always cancel out. We've seen that for a long time. So negative 2 root 3, positive 2 root 3, those go away. Look, I don't have any radicals now in the denominator, and that was the point. The denominator, in fact, has simplified very nicely. It looks like it's just 3 take away 4, which is negative 1. 3 divided by negative 1 actually does have a nice answer. It's just negative 3. I don't even have a fraction anymore. And since I don't have a fraction, there's certainly no reason to leave this factored out, so I will now go ahead and distribute. I end up with negative 3 root 3 for the first term, and then plus 6. And that would be the final simplified answer. So again, when you're doing these problems, you just want to be paying attention. Well, how many terms do I have down at the bottom? If it's only one, then you can use all those tricks from the last video. But if there are two terms, then you've got to use this multiply by the conjugate trick in order to get the answer. Okay, let's look at one other example to demonstrate this. This one has some variables in it. It might look a little messier, this example, but in fact, it's really just the same thing, the same idea. Obviously, one of the things you've probably realized is that you have to pay close attention to where these square root symbols end, right? So this x is the only thing in this square root. The minus is outside, and then there's a new square root here with the 3. My job is to simplify. I'm looking at this thing thinking, well, I don't really see what I can do other than try to rationalize the denominator, try to get rid of those radicals in the bottom. So I'm just going to use that same trick. I'm going to go and I'm going to multiply the top and bottom by the same thing. What am I going to multiply by? By the conjugate of the denominator. And then I have to do the same thing up here on the top. Parentheses again might be helpful for actually doing the various multiplications. So once again, I'm pretty confident that I'm going to be distributing that top here in just a second, but I always like to wait and see what happens in the denominator first. We can probably do this a little faster now, because after you realize how the conjugate thing works, you know that the inner and the outer products always cancel out like they did in this example. So all I need to really worry about is root x times root x. Remember, square root times an exact copy of itself. That's going to leave me with just x. The outer and the inner disappear. And then the last looks like a minus. Negative times positive is negative. And then root 3 times root 3 would just be 3. Again, if it helps you to write root 9 and then in the next step realize that that's a 3, that's completely fine. Be careful here when it comes down to looking for things to cancel and so forth. I'm not looking at factors on the bottom. This is a giant subtraction problem, and it does not factor, so there's no canceling in this problem for sure. Now that I've established that, there's certainly no reason for me to leave this so messy. I should certainly distribute this out. It'll make it a lot nicer looking. Root x times root x is just x, so that's certainly simpler. Plus, let's see, root x times root 3, you can multiply two square roots by simply multiplying the pieces on the inside. So 3 times x would be 3x in there. And then the bottom is x minus 3. Certainly not a very nice looking answer, but this is considered the best answer possible, the nicest answer we can get. There is no way to go any further because I cannot factor the bottom. So this is it. This is the final answer to the problem.